this video we're just going to have a little bit of a play around with some algebra. So this time we're going to be given the value of Kc and the rest of the equilibrium concentrations, and we're going to try to find a remaining one. So in this example we've got equilibrium concentrations for nitrogen and hydrogen, these two. We've got a value for Kc and we're being asked to find the value for the ammonia, the concentration. So we've not got to do much, just a bit of rearranging. So start in the same way. Write an expression for Kc. You don't need to find its units this time because they're given in the question. So just write an expression for Kc. Can you then rearrange that expression to make ammonia concentration the subject? So let's work through those steps. The first thing I'm going to do is I'm going to multiply both sides by nitrogen concentration and by hydrogen concentration cubed so that I get rid of it off the bottom line on the right hand side. So I'm going to multiply both sides by the nitrogen concentration and the hydrogen concentration cubed, and that will remove it from underneath that fraction. So then how would I get ammonia on its own? Well, if I want the concentration of ammonia, and at the moment it's squared, I'm going to have to do the square root of both sides. So that's everything together on this other side. I'm going to have to do the square root of. And now we're going to substitute our numbers in to find the value for the ammonia concentration. So substitute your values in and see if you can work it out. So I've given it to two significant figures. I've used the square root button on the calculator, and on a Casio calculator that will continue square rooting until you decide to come out of that square root sign. So you can just type 2 times 2 times 2 cubed, and if you don't have a cubed button on your calculator, you could use the X to the box, but most Casio calculators do have a cubed button. So that would be how you would rearrange to find a concentration. The units of concentration are just moles per decimeter cubed. I didn't have to work that out, they are the units of concentration. So here's another question for you to have a go at. We've got the value of Kc, we've got the value at equilibrium of the 3 of the concentrations, and we have to find the fourth. So step 1, write the expression for Kc. Step 2, rearrange it to make this the subject. So the first thing I would do is multiply both sides by this and this, the two bottom things, to get rid of them off the bottom. So I'm going to do that first. So I'm going to have Kc times by ethanoic acid concentration times by ethanol concentration equals ethyl ethanoate concentration, the one that I want, but we're still multiplied by water concentration. Right, so my next step would be to get the ethyl ethanoate on its own. I'm going to divide both sides by the water concentration. Now it's common to put the subject first, so I'm just going to do that. Doesn't make any difference, it's on the equal sign. I'm just going to... So remember, I'm dividing both sides by water concentration. So why don't you put your numbers in and see what answer you get? So again, I advise using the fraction button on your calculator. If you do that, you should get this with some more numbers, but 3 significant figures is appropriate for this question because that's what they've used. You might think, well, that's weird, it's the same as one of the other numbers, but it's not that weird to assume that you would get the same amount of one product as you did the other if you start with 0 of both of them. Okay, so it's not that weird to get that amount. That's just a bit of algebra and rearranging.